All right, this is second grade Module 7, Lesson 22. Now, parents and teachers, in this lesson, we're going to be connecting the idea of addition and subtraction, specifically two-digit addition and two-digit subtraction, with the lengths on a number line, using that ruler as a number line. So we're connecting the operations of addition and subtraction to a number line, but we're connecting that number line to a ruler. And all of this is to build understanding of mathematics, so math can be based on a firm foundation of what a student understands rather than just being a bunch of rules that students are supposed to memorize. So let's get started.
So I'm going to focus on this pencil and the number line for a second. So we have a pencil and we want to know the length of this pencil on a number line here. And let's say this is all centimeters. It's not drawn to scale, but let's pretend these are centimeters. And so the idea is we want to know the length of this pencil. So one way is we could say, well, 49 plus something equals 62, and that something is the length of the pencil, and that will give us 62. So 49 plus the length of the pencil gives us 62. So that's one way we can connect this number line to an equation. Now, of course, once you have an addition with a missing addend, that means it's also 62 minus 49 equals that same length of the pencil. So you can see, all right, 62 minus 49 is going to give us the length of that pencil. Now here's a really cool thing, because we have learned that, let's make this a little smaller, let's make this a little smaller. All right, so we have learned a really cool trick earlier in an earlier module, that this pencil is not going to change lengths. So if instead of doing 62 minus 49, which gets a little complicated, especially if we want to try and connect that with the stacked method, 62 minus 49, all right, because now we have to do some regrouping and stuff. The idea is what we could do with this pencil is we can nudge it up 1 centimeter in this case. And the reason we're going to nudge it up to 1 centimeter is it brings the tip to a nice decade, in this case 50, all right? And now what do we have? Well, it's the same pencil, but our equations are going to change. Our equation now becomes 50 plus something is equal to 63. Or we could think of it as subtraction. We can say, well, that's 63 minus 50 equals our box. Or we can also think of it in that stacked model, which is 63 minus 50 equals. Now this is the standard algorithm, and in this case we see that, hey, there's no regrouping necessary at all, and we can see that our pencil is 13 centimeters in length, which means all of these answers are 13. All right, all of them, because that pencil isn't going to change length depending, just because the expressions are a little different over here compared to here, because what we did, took that same pencil and we just nudged it. All right, now if we had nudged it up to here, we would have gotten, 64 minus 51. And if we subtracted there, we would still get 13, because that pencil never changes lengths. We just kind of move it up and down the number line. And of course, we nudged it up 1 to make our problem simpler, but we didn't have to nudge it up 1. We could have nudged it up 2, like up here. So that's how we're going to be connecting a number line to the ruler, to the variety of different operations, addition and subtraction with 2 digits. So here we are specifically told that each unit length on both of these number lines is 10. All right, and that's a key thing. So it says show 20 centimeters more than 35 centimeters on the number line. So what we're going to do is we're going to first locate 35, and I've decided to put it there. I could have put it here or here or here. I chose to put it here. So each hash mark is 10. So if I want 20 centimeters more, I would do 10, 20, and so there's my 20 more, so that gives us 45 and 55, and that is 20 more on the number line. Now, down here it says write the addition sentence to equate what we just did. Well, that is, I'm going to squeeze it in up here, that was 35 plus 20 equals 55. All right, there's our addition sentence. 35 plus 20 gives us 55. Now down here, show 30 centimeters more than 65. All right, so just to be a little bit different, let's put our 65 right here. And now we're supposed to show 30 centimeters more. So 10, 20, 30. And so that gives us 65, 75, 85, 95. So there's our answer. And if we want to write that as an addition problem, that would be 65 plus 30 equals 95. Again, it's more of the same, only this time it's subtraction. I'm not going to do both problems. Let's just do problem A. So it says show 35 yards less than 80 on this number line. Now here's the key thing. Each length represents 5 yards. So I'm going to start way over here. There's our 80. And I'm going to go backwards 35. So we need to count by fives, right? So that's going to be 5, 10, 15, 20, 25, 30, 35. So I just counted back 35. So that is our location of our answer. What did we end up with? Well, let's do that. Let's count. So this would be backwards 5 is 75. Backwards 5 gives us 70, then 65, then 60, then 55, then 50, and then 45. So what is our subtraction sentence for this? Our subtraction sentence is going to be 80 minus 35 equals 45. Because here's our 80. The minus 35 is all of this, equals 45 because that's where we ended up at. Now, I'm choosing this one to show parents and teachers largely because I really think this drawing is really kind of confusing and I don't like it. And so let me tell you why I don't like it. With all due respect to our Eureka math friends, we like them, but this is clearly an editing issue. So the idea is, I'm going to zoom in right here, and the idea is this 37 kind of looks like it's in the space, and it's just a little, yeah. So what I'm going to do is I'm going to erase that 37 centimeters, and I'm going to write it in a way that is a little bit more appealing to me. I'm going to put 37 centimeters right here because we want the measurements to be directly related to the hash marks, not to the spaces in between. And when I scroll over here, I really see some more confusion here. Same kind of confusion. In fact, you'll notice the screwdriver ends right here, but this arrow is a little confusing. So I don't think that arrow should be there in that space. Really, that arrow should be right here. All right. And then the 51 shouldn't be located in the space. The 51 should be clearly connected to a hash mark. So I'm going to erase that 51. And I'm going to put it where I like it a little bit better. So parents and teachers, if you have the ability, go ahead and go directly into the doc, which you could download from EngageNY.org, and edit it. directly there. All right, so the other thing is we have the same issue in this other tape diagram here. So I'm going to do some erasing, and I'm going to erase this 37.5, 37 centimeters, because I don't like where it is. 37 centimeters, I like that better. It's directly connected to a hash mark. And then over here, again, that arrow is in a space when really it should have been at a hash. So I'm going to erase that arrow, and I'm going to put in that hash right here. And then we're going to also erase this 51 and put it directly under a hash mark right here, 51 centimeters. So now the figure is, I don't know, a little bit more precise. All right, it's the way I think it is intended to be. So the idea is, now we can go ahead, and Laura's meter strip got cut off at 37. To measure the length of her screwdriver, she writes 51 minus 37. That makes sense. That's perfect. Everything Laura is doing is correct. Now Tam says it's easier to take that screwdriver and bump it up 3. And if we bump it up 3, what do we end up with? Well, instead of the screwdriver being at 37, the end of the screwdriver is now at 40 centimeters. And the tip of the screwdriver, instead of being at 51, is now at right here at 54 centimeters. So Tam's idea, where Laura's idea was 51 minus 37, Tam's idea becomes 54 minus 40. And that's probably a little bit easier to do because there's no regrouping necessary. You see, Laura's method, 51 minus 37, would have required some regrouping, parents and teachers. So the idea is we do want students to be able to take a subtraction problem, modify it to an easier subtraction problem that gives us the exact same answer. So in this case, we know that the screwdriver is 14 centimeters long. And why is Tam correct? Well, she's correct because we didn't change the length of the screwdriver. We just bumped it up to make it into an easier subtraction problem. Now Alice measured her belt to be 22 inches long using a yardstick, but she didn't start her measurement at 0. What might the two endpoints of her belt on her be? What might be the two endpoints of her belt on her yardstick? So write a subtraction sentence to support your idea. So if we know her belt is 22 inches, we could have started right here at, let's make it 15 inches. And then her belt could be right here. And then here's her belt buckle right here. And then the dot, 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 dot on her belt. And so this belt right here could be 22 inches long. So where is she going to end up? So the idea is, and we're supposed to use a subtraction sentence, not an addition sentence. So that's going to be kind of tricky, right? So what is this point right here? Well, we are going to use addition and say, well, 15 plus 22 gives us 37 inches right here. And so what would the subtraction sentence be to match the length of this belt? Well, it would be 37 minus 15. Now when we do that, 7 ones take away 5 ones gives us 2 ones. 3 tens take away 1 10 gives us 2 tens. And so we end up with 22 inches, which is exactly what we wanted. So what are the two endpoints? Well, one option could be 15 and 37 inches. Definitely not the only two options, because remember, we could be sliding this belt up and down the number line, and we could have an infinite number of options for our endpoints. And that wraps up second grade Module 7, Lesson 22, representing sums and differences on a ruler and a number line, kind of connecting those two physical concepts to understand that standard algorithm.